All right, so we discussed the runtime of a good hashing function, not our hashing function, which is not good, but of an actual good one. It should be constant time, at least most of the time, which is really what we're concerned about with Big O anyway. There's always going to be deviations. Now, how about a hash table implementation? So here's kind of a wishy-washy table. Setting on a hash table should be constant time. All we do is run the hash function. It should be constant O of 1. Getting and checking if a value is there, retrieving a value, mostly constant time. Deleting is mostly constant time. And then getting all the keys or the values or the entries in some sort of iterable is linear, O of n. Now, why mostly constant time? What does that really mean here? So fundamentally, an ideal hash table can be constant time. But that's assuming we don't have collisions and that the array is perfectly sized. Because we could have some massive array or we could have some tiny array and it's too small and now we have a bunch of collisions. So the key to getting close to a constant time hash table is choosing the right array size in order to store your information as close as possible without collisions. And we also want to choose a hash function that spreads keys evenly across an array. That way we can also hopefully minimize collisions. But even with a perfect hash function, we're going to have collisions, technically there is a thing called a perfect hash function, but with a near perfect hashing function, collisions are practically unavoidable. For example, if we had 2,450 keys hashed into 1,000,000 separate buckets, even with a perfectly uniform random distribution, there is approximately a 95% chance of at least 2 of the keys being hashed to the same slot. It's kind of interesting. If you want to learn more about this, there's a fun little problem or this paradox called the birthday problem, where you have some random number of people in a room and there's a high chance that some pair of them will have the same birthday. Same thing applies here with hashing functions. So even if you have 1,000,000 empty slots, 1,000,000 buckets, if you're just hashing 2,450 elements, there's a 95% chance that there will be a collision. Thankfully, we've talked about some collision strategies. And this idea of separate chaining, it's actually the only one we've talked about so far, where we store elements in a bucket inside of a bucket. We group them together. Typically, a good implementation of a hash table or hash map will have a maximum size for each bucket and cap that at 2 or 3 at most collisions in a single bucket. And then if needed, there are other strategies. So if we do have a predictable number of collisions, if we say that there's a maximum of 3 elements in each bucket, we can call that constant time. If we had an unlimited number of elements in a bucket and we somehow had a bad hashing function, then we could be talking about something as bad as O of n, linear time. If you had 100 or 1,000 or 1,000,000 elements all grouped together in that same bucket in the hash table, it kind of defeats the purpose. You're going to need to revisit that hash function anyway. But if we have 3 operations or 5 operations, as long as that's constant, we just call it O of 1. O of 10 is the same as O of 1. O of 3 is the same as O of 1. Now, another thing to consider with hash maps or hash tables is resizing. Most of the good implementations, the native implementations in languages, are actually going to dynamically resize. They're going to shrink or grow the number of buckets, the array that they're using, hoping to keep it around 75% occupied. And that obviously takes time. The resizing is definitely not constant time. And that means that occasionally a set or a delete call will take longer if the hash table, if that bucket list, if the array is going to double in size or halve, or if it's going to shrink or grow. That is not constant time, but that can make ensuing calls and ensuing retrievals of data much faster if we can prevent collisions. We can make sure that our array is sized to just the right size with a little wiggle room, but we don't want it to be way too big and we don't want it to be way too small where we have 1,000,000 collisions. So these are things you don't really need to consider yourself. You're not going to implement very many hash maps from scratch. These are structures that are implemented already in most languages, but it's good to know how some of them work behind the scenes. So you have to have a good hashing function, and you've got to have a good hash table that's able to handle collisions and resize when appropriate.